Hi, everyone. I'm Shelly. I'm a security engineer turned product manager. I'm currently working at Opal Security and previously was doing infrastructure security, platform security, SecOps, detection response at a handful of companies. I'm personally a huge fan of B-Sides, whether that's in San Francisco or Las Vegas, and I'm really very excited to continue being involved in the New York scene. I'll pass it on to Steven to intro himself.
Hi, everyone. I'm Steven. I also work at Opal, where I'm an engineer. Previously, I did a bunch of different things like building and securing all servers and developer platforms. And just thank you all for joining our talk today.
All right. So today we're going to be talking about protecting Snowflake and critical data systems from unauthorized access. Hot topic, yes. But before I do a deeper dive, I do want to zoom out to talk a bit about why we decided to do a talk on Snowflake and specifically critical data systems. If you've had to conduct threat models or impact analysis, or you yourself are a red teamer, you're probably well aware that the more sensitive or valuable a system is, the more attractive it is to attackers. You've most likely heard of these systems referred to as crown jewels, or NIST, because no security presentation is complete without quoting some sort of standard. NIST calls these high-value targets. Now, the definition of these critical systems will differ for each organization. For example, the crown jewels for a hardware manufacturing company will look very different from those of a banking software company. Still, if we generalize, we'll notice that a lot of times these systems are ones that host data such as customer data, think about first name, last name, phone number, addresses, or intellectual property. Maybe that's proprietary code base, algorithms that allow your company to run, social media, key financial data. A lot of folks forget about HR employee data or people information. Cryptographic key material is also one of the items there. You don't want your encryption keys floating around in the ether. Data protected under regulations such as PCI and GDPR. So again, sort of that PII type of data. And as well as business critical services. So think of these systems as the ones that allow your company to keep running. So what does that mean for a company when thinking about securing access to these types of critical data systems? You can generalize it into roughly 3 phases from a process perspective. First, there's the identification phase, right? In this phase, you really want to think about inventorying your critical data systems. Usually that's in the form of maybe your SaaS apps, your cloud providers, internal tools, infrastructure, etc. So as an example, maybe it's your AWS S3 bucket, GCP, maybe it's your BigQuery data set. For the purposes of our talk, Snowflake databases or Snowflake tables, as an example. Once you've figured out what's sort of in your estate as a critical data system, you want to be able to centralize and apply best practices. So from an access perspective, this looks like implementing multi-factor authentication, single sign-on for authentication purposes. From an authorization perspective, also just-in-time access, making sure that you don't have long-standing access to privileged roles. You also want to think about tracking human and non-human identities in a centralized place. And culturally, you want to be thinking about training the organization to request access only when they need it. Once you have the best practices in place, then you think about optimizing, right? And so if you don't already have detection and response capabilities in place, setting those up. You want to be able to support continuous and conditional access. Maybe you even use behavioral analysis or cohort analysis to generate recommendations for right-sizing privilege, right-sizing roles. So with this in mind, let's shift our focus onto Snowflake. Snowflake is a data-rich platform, and just one example of when many companies will consider a critical data system in their environments. It's especially top of mind, as you all probably know, given the buzz in the last year or so, due to increased activity by attackers to gain access in their environments. It's to Snowflake customer environments. If you're a concert goer, as an example, and you have used Ticketmaster, you may have recently received an email from Live Nation saying that your data was compromised. So in this specific incident in the April, May, June timeframe, researchers at Mandiant found that the attacker acquired Snowflake credentials from InfoStealer campaigns. These creds then granted them access to read and exfiltrate customer data from Ticketmaster's Snowflake tables. And just to give you a sense of the magnitude and to put a number on the cost, researchers say that this amounted to roughly $500,000 worth of data. So talk about valuable targets. While situations like this will inevitably happen in our industry, controls such as MFA, again, short-lived access, and further scope down roles could have helped to limit the blast radius. I'll go ahead and share a couple of best practices in the next slide. So I just want to be explicit here and take a step back. This is not meant to be a knock on Snowflake or its customers. If anything, it's really to highlight how important it is to secure access to popular and high-value data systems. Snowflake is just one example that is widely used. All right, so as mentioned, here is a short list of best practices that we've gone ahead and compiled for securing access to Snowflake. It's compiled based on their own best practices docs, CIS benchmarks, and other standards. So to start with, again, enable MFA and SSO for your account and organization. Second, implement role-based access control via custom roles. And this is particularly pertinent for Snowflake because of how crucial roles are in their access model framework, which Stephen will talk about a little later. Third, configure account level or user level network policies. This helps when you think about it in a defense in depth perspective, so you can have both the identity side as well as the network side. Then we talk about controlling the assignment of the account admin and security admin roles to users. So again, this is about limiting privileged access. Number 5, you could think about it as implementing policies around use it or lose it. So if someone who has not logged in or used their resources for about 90 days or less, you can revoke their access. Lastly, we'll talk a little bit about setting just-in-time or time-bound access to privileged roles. So again, this might be roles such as account admin and security admin, which have a lot of access within the Snowflake environment. So I've bolded this because Stephen is actually going to walk us through an actual implementation of this, since best practices are always there for reference, but to actually do this in your environment takes an additional step. So
All right.
go for it.
Thanks, Shelly. So as we know, Snowflake at its most basic level is a data storage platform. Their customers leverage their platform for a multitude of different use cases. So Snowflake built an access model system that is highly flexible and designed to give you granular control over your data. There's a good amount of depth to it, and we don't have time to go over all of it, but I'm going to give you a high-level overview of some of the key concepts. So the core entities in the access model are pretty standard. You have users, securable objects, privileges, and roles. A user is any human or non-human identity recognized by Snowflake. A securable object is anything that can have access permissions granted or revoked, such as a database table. And a privilege is an operation that could be carried out on a securable object, such as executing select on a table. Privileges can't be directly granted to users. They must be granted to roles, which are then granted to users. So what is a role? There are multiple kinds of roles, but I'm going to talk about custom roles as that's what makes Snowflake's access model so flexible. Essentially, they're a collection of privileges which give users granted the role, the ability to perform actions on securable objects. So if my user is granted a role with select privileges on a table, I'd be able to query data from that table. What makes roles so powerful is that they are composable and can be assigned to other roles to create a role hierarchy. So here we have an example role hierarchy. You have your system-defined roles at the top, like account admin, and below that you have custom roles like read-only and engineering. Roles higher in the hierarchy inherit all the privileges of the roles below them. So for instance, account admin inherits from sysadmin, which in turn inherits from engineering, and so on down the hierarchy. A typical way of managing roles is to create access roles and functional roles. If we look at the diagram, the access roles would be the read-only and read-write, and these would only contain privileges. Functional roles, on the other hand, typically align with job function. In this case, that would be the engineering and sales roles. These normally inherit all their privileges from access roles and are only assigned users and other functional roles. So you may end up having functional roles for engineering and sales, which mix and match all these different access roles to inherit the privileges needed to perform those job functions. So if we look at the diagram, the engineering role is granted read and write privileges, while the sales role only has read privileges. So as you can see, Snowflake provides a great foundation to secure access to your instance. You can leverage those building blocks to build tooling that further improves your security posture by following best practices like just-in-time. But before I get into how you may implement just-in-time access, let's first talk a little about what a standard flow may look like. If you're a Snowflake admin, you probably get flooded with requests from employees trying to get access. You may have them create a ticket, then have some back and forth discussions trying to understand what permissions they need. And now on top of keeping all the infrastructure up and running, you need to find some time to work through the queue of access requests and fulfill them. A process like this tends to be very slow and repetitive. Additionally, if you're not routinely auditing and revoking grants, you may end up with access sprawl, and now you have to clean up a bunch of privileges employees are not actively using. So what does just-in-time look like in practice? First, limit the roles a user is granted at any given time. So instead of granting a role indefinitely, the grants expire and are automatically revoked after a predetermined time. This time-bound approach helps prevent access sprawl and eliminates the need for anyone to remember to revoke permissions when they're no longer needed. Further, building tooling and automation will allow your team to scale this practice. So when an employee needs access to something, they would create a request. Depending on the sensitivity of the request, it may automatically be approved or go to someone for manual approval. And once approved, access is provisioned without any human intervention. Then when they're done doing what they need to do, the grant will eventually expire, or they can forfeit their access with a click of a button and permissions will automatically be revoked in Snowflake. So this keeps the team out of the hot path and frees them up to do more valuable work while still allowing them to oversee the process. And now that we spoke a bit about the user experience, you may be wondering how you can go about implementing just-in-time access at scale for your Snowflake instance. A basic implementation requires configuring a service count, scripts for granting or revoking roles, and a way to execute those scripts on Snowflake. So let's begin with the service count. Setting one up requires a few things: authentication mechanism, a role that contains all the privileges needed for the service account, and a user that will be acting as the service account. Snowflake provides several ways to authenticate, but recommends using key pair authentication when working with service accounts. This involves generating a public and private key, which is used to mint a JWT. Then when you're making a request to Snowflake's REST API, for example, the JWT is passed along as a bearer token. One nice thing about key pair authentication is that the user can be associated with two public keys, making rotating keys without any downtime pretty easy. And now once you have your public and private key, we create a role, and that will be granted, a role that will be granted to our service account user. This is technically optional, but I think it's cleaner and provides better auditing because it's easier to see what actions are performed by a service account versus a role that is also granted to human users. At a minimum, the service account needs to manage grants privilege, which allows it to grant and revoke roles. And then finally, we create the service account user, assign the public key we generated earlier, and grant the service account role to that user. And now that we have our service account configured, let's take a look at how to grant and revoke roles. You only need a few simple commands. First is the grant role command, which is used to grant a role to a user. Then, equally as aptly named, is the revoke role command, which, as you might be able to guess, revokes a role from a user. Lastly, you can view all grants of a role using the show grants of role command. And with these basic commands, you're halfway there to implementing just-in-time access. So with our service account set up, our scripts ready to go, let's explore a sample architecture that brings this all together. We have a few components going on here, and depending on your organization size, this might be overkill, might not be enough, but it's a starting point, and you can downscale or upscale it as needed. So let's start off by looking at the granting workflow. The server receives an approved access request. The details of that request, such as duration and the role, are written to the database. A job's queued. It gets picked up by a worker, which sends a grant role request to Snowflake. If all goes well, user should have their shiny new grant. Forfeiting access is virtually identical, but instead of executing the grant command, the worker issues a revoke command to Snowflake. And finally, for expiring asset access, you might want to utilize something like a cron job. It checks the database for all grants that have expired and queues a revoke job for each one. The worker picks up the job, issues the revoke command, and a grant will be yeeted away. So in case you feel inspired to create your own just-in-time system, I'd like to share some lessons we learned while building ours. One essential task is retrieving all users, roles, and grants. You can do this using either show commands or by querying the account usage views. Each method has its trade-offs though. For instance, show commands offer limited filtering and a maximum of 10,000 rows, while account usage views provide more comprehensive data, but with a 2-hour latency for the latest system state. Your choice will depend on your organization's size and specific use cases. One notable advantage of show commands is that they don't require a running warehouse, allowing you to query information without consuming credits. This can be a nice cost-effective approach if your needs fit within that 10,000 row limit. And additionally, when using the REST API, always use bind variables to prevent SQL injection attacks when incorporating any user input to your queries. And that's it. I hope these insights help you on your Snowflake journey.
Awesome. Thanks, Stephen, for walking us through that. So I just wanted to do a quick recap on what we talked about during this engagement. So we started out by talking about securing access to critical data systems like Snowflake. Then we talked about how important it is for you to be able to inventory your crown jewels or your high-value targets. Then we talked a little bit about scaling least privileges using a 3-phase approach. So again, that's identify, centralize, and optimize. And we also gave some best practices for access control within Snowflake. Then Stephen gave you a quick overview of the Snowflake access model and also showed us how to actually implement just-in-time for your Snowflake environment. So at this point, we'll go ahead and wrap up. If anyone has any questions, feel free to come find Stephen and myself by the Opal booth, or just come up after this talk as well. We're always happy to chat, talk about security, talk about identity as well. And with that, we'll open it up to questions.
So what's that mechanism look like with the just-in-time after you've created that for the user experience? So how is the user then doing that?
So you would have, like in our instance, we have a web portal where they look up what they need, submit a request for it that includes the role, how long they need it, why they need it, and then that comes into our system. We have different branching rules, whether like if the resource is tagged as sensitive, it might require to go through multiple approvals, or if it's something that's just more like it's not sensitive, we might just auto approve it and then it goes through that like whole system that I showed earlier.
This whole implementation that you guys put together, was this done post or pre-breach of Snowflake?
This was done, I guess, to answer that question specifically pre-breach, and it wasn't necessarily a reaction to some of the news that came out recently. It's more just as we were thinking about some of our critical data systems, as I mentioned, we figured that like we do want to protect our most sensitive resources. And so thinking about like maybe it's not just Snowflake, it's our other systems like AWS, like GCP, et cetera. This is just like a flow that we kind of can implement more generally across systems.
All right.
Cool. I'll go
Thank
and
you.
wrap up.